Okay, for this set of problems, we're going to work with the binomial theorem. And to start, we're going to not simplify. We're just going to be focused on the setup. Okay, so for the first problem, we want to write the first three and the last two terms of the expansion of 2x plus 1 over x to the 12th power. So if I'm going to work with my binomial theorem, I understand that I have a pattern to use that will allow me for working with my binomial coefficient as well as working with the terms in my binomial. Okay, so how do we work this? For this first one, I have raised to the 12th power. So my first term will be 12, choose 0, then 12, choose 1, then 12, choose 2. So my third term is going to be 12, choose 2. Now, for my last two terms, my last term is 12, choose 12, and the second to the last term would be 12, choose 11. Okay. Next, I have 2x as the first item, the first object in my binomial. So I'm going to have 2x set up into each of these. So there's 2x, 2x, 2x. Okay. And then I have 1 over x as my second object in my binomial. So 1 over x, 1 over x, 1 over x, 1 over x, 1 over x. Then, for our purposes, the way we will be expanding, right, this 0 is going to correspond to the exponent of my second term. So I have 1 over x to the 0 power, 1 over x to the first power, 1 over x to the second power, on to 1 over x to the 11th, 1 over x to the 12th. And the power for the 2x term in this case, right, where we had 0, 1, 2 and increasing for my second term, right, for that first term, I'm going to end at 0 and then go to 1, and then this one is going to be 10, and here's going to be 11, and here's going to be 12. Right, that's the pattern that I'm going to use. And notice that the sum of the powers, 12 plus 0, should equal the total power that I'm working with. 11 plus 1, 10 plus 2, 1 plus 11. So that would be writing down my terms within my expansion, okay, and not simplifying. Okay. Commonly, if I simply were to write down the terms, I would need to simplify each of these items to a point. Right, before right now, can we do this? Okay. For part B, we want the 7th term in our expansion. So my 7th term is going to be 14, choose 6. Right? Why 1 less? Well, notice my first term starts at 0. My second term is with the 1. My third term is with the 2. Right? So this means that this 11 represents my 12th term, and this 12 represents my 13th term. So if I want the 7th term, 14, choose 6. Then I'm going to have 3x, and I'm going to have negative 4 over x squared, and the negative 4 over x squared is going to be to the 6th power, and the 3x is going to be to the 8th power. Okay. Now, we're asked not to simplify here, but if I wanted to simplify, this would be given as 14 factorial divided by 8 factorial, 6 factorial, the 6 because of here, and 8 plus 6 is 14, right? And then we would have 3 to the 8th power, x to the 8th power, from the 3x to the 8th power, and we would have negative 4 to the 6th power all over x to the 12th power, because x squared to the 6th power is going to be x to the 12th. Right? So that in the end, Right? In the end, what I would have here then could be represented, not fully simplified, but could be represented by 14 times 13 times 12 times 11 times 10 times 9 divided by 6 times 5 times 4 times 3 times 2. And there is an implied 1 there, so we'll go ahead and add it. Right? And that's because 14 factorial divided by 8 factorial is just going to be 14 times 13 times 12 times 11 times 10 times 9. Right? The 8 factorials there will cancel. And then I'm going to have a 3 to the 8th power. And I'm going to have that negative 4 to the 6th power. And then x to the 8th and x to the 12th. That would leave me with an x to the negative 4th power. Right? So this isn't fully simplified, but we see how we could take that information out further. And in fact, over here we could simplify and cancel some things a bit more if we wanted to. Right? I could say that 4 times 3 is 12, so I could cancel this 12. Right? That 12 cancels that 4 times 3. I can say that 5 times 2 is 10, so that would cancel there. And I could say that, hey, you know, this 6 is really 2 times 3, so I could cancel this 6 and let that 14 become a 7 and that 9 become a 3. And all of a sudden, I have a slightly easier item to compute. All right? But realize this problem is without a calculator, so what we have in blue is what we would expect you to be able to write down. And if the numbers were a little bit nicer, be able to further expand. And then finally, C, I want the constant term. So this is the term with x to the 0 power. I want the term with x to the 0 power. So how can I solve that? I know I have 15, and I'm going to say choose r. I've got to figure out the power I want to use. Right? And then this is going to be x over 3 to the 15 minus r power. And then it's going to be multiplied by negative 2 over the square root of x raised to the r power. Okay, so we need r such that we get x to the 0. We need r such that we get x to the 0. So let's just focus on the x terms. So this is x to the 15 minus r times x to the negative 1/2 raised to the r power, because dividing by the square root of x is like x to the negative 1/2. So what does that mean for us? That means the following, right? That this can be written as x to the 15 minus r minus 1/2 r, or in other words, x to the 15 minus 3/2 r. So therefore, I need 15 minus 3/2 r to equal 0. Multiplying both sides by 2, I have 30 minus 3r needs to equal 0. So therefore, r needs to be 10. Okay. So if I do that, if I know that r needs to be 10, this is going to be 15, choose 10, x over 3 to the 5th power, and negative 2 over the square root of x raised to the 10th power. Okay. Now, we aren't asked to find the constant in the simplest terms, but this is going to be our constant, right? That we're going to have, if I wanted to proceed further with this, I'm going to have 15 times 14 times 13 times 12 times 11 times 10 factorial, because that's 15 factorial, divided by 10 factorial times 5 factorial, right? 10 and the 5. And then have x to the 5th power over 3 to the 5th power, and have 2 to the 10th power and x to the 5th power, because the square root of x to the 10th power is going to be x to the 5th. Negative 2 to the 10th power will be 2 to the 10th. Okay. If we were doing this without a calculator, we might come through and say, well, these 10 factorials are going to cancel. And these x to the 5ths are going to cancel, which is what's going to result in me having a constant. And then I know that 5 factorial is 5 times 4 times 3 times 2 times 1. So 5 and 3 is 15. All right. This 4 can cancel that 12 to leave that to be a 3. This 2 can cancel that 14, let that to be a 7. And so I have 7 times 3 times 13 times 11. Right? And this 5 factorial would have had everything cancel. And so I could say this is going to be 21 times 13 times 11 times 2 to the 10th power all over 3 to the 5th power. Right? And in fact, I could simplify that further still. I could simplify that just a little bit because I know that 21 has 3 as a factor. So really I could say that my constant is 13 times 11 times 7 times 2 to the 10th is 1024. So times 1024. And then this being all over now 3 to the 4th power. And that would be a prime factorization of my constant, actually. Because notice I've reduced everything to be with prime factors, where of course that 2 to the 10th is 1024. So organizationally, we do need to understand how to set up each of the items in using our binomial theorem. Okay. Thank you very much for your time.